Here's our code for Machine Learning Project 4. I'm going to run through everything real quick. So here's the the multi-layer perceptron neural net. It also has backprop in it. So right now we are set up to run backprop, iterate 3,000 times with a momentum of 0.05. So down here as it runs, you can see our fitness. Um, that number along with the total number gives you your accuracy. Up above that is just us normalizing the data to numerical values. So as we can see, our 3,000 runs, looks like our fitness ended up being 14%, which is not fantastic. We could possibly get a better number with better tuning. We found that the random initialization of the weight function was really having a big effect on it. So we're still trying to figure out how to improve that. After our performance here, which was updating as we ran, we've got breakdown of how many were classified per class, so we could get an idea of the diversity, figuring out where our local maxes were. So we're getting stuck a lot of places where it would identify one class really well and then not go out to identify other ones. So looks like this run was pretty good. And then, of course, this second one here is just how many options for each class we have. So for this first class, we identified 64 of the 966 entries in that class. So that is MLP with backprop. The MLP also has a standard just run function that doesn't iterate through or update the weights. That GA, PSO, and diff evo all plug into. So let me run those for you. Alright, and then so for our GA, just scrolling through this real quick, it goes through, got population size, all of that. So go ahead and run this real quick. You're going to see every single individual in the population has to check their fitness. So every time the MLP runs, it's going through here. You'll see as we go on that this number correctly classified on the left here goes up towards the end. And from that and number of iterations, you can calculate your accuracy. On the left here, these graphs, again, we're using the car data just so that we can run stuff fast enough for the video. So the left-hand side is how many were correctly classified, broken down by class, and then the right side is how many are available in each class to be classified based on the training set that was passed to this. And so this function actually, what we are doing is running it multiple times to be able to tune it and make it better. And so it would print out a graph using this matplotlib.pylot function. However, I wasn't able to get that to run fast enough to get in the video. So then going over to particle swarm implementation, it goes through each particle is holding a copy of the weight matrix, which it updates both with its global best and personal best. So if I go ahead and run this, we'll see down here is the optimized weight matrix that it came up with. So from the particles, I believe we only had one run here with these. So it would have picked this individual here, had the highest fitness of 966. It doesn't have great diversity right here. However, with more iterations, it generally was finding better optimization than that. So we could run it through more times, but that is general overview of that. Alright, and just quickly scrolling through differential evolution. Got max runs, population size, all of that stuff going on. Our run function here, going through the population and picking our most fit individuals. using same generate weights function that we used over in the MLP neural net file. So that is a general overview of our fourth lab.